Hello, ladies and gentlemen. So it's going to be a two-voice presentation. So we're going to talk about IoT, but more on the connected object side. So we are STMicroelectronics, we are a silicon vendor. And so we present to you what we see as a connected object and what we are developing around the STM32 Nucleo platform for those connected objects. So the presentation will be on two parts. I will take care more about the introduction and the marketing slide, and my colleague Daniel will speak more into detail about the software and tools we are proposing. So I'm starting with two examples, which are examples coming from Grenoble. So this is example of connected object. So this first one is called Pew Pew. I don't know if you heard about it. So this guy is not an engineer, simply he's a pure Grenoble guy. He likes the external sports and he likes flying. So he was missing something just to know exactly what was the wind and the weather condition for the sports he liked. So he decided, taking the available technology, to develop something new, which is a low-cost weather station that wants to be connected and sharing all the information with the other people from his community. So he's in the process of developing his tool. So this one is this picture is a prototype. It has changed. Sorry. So this one is a prototype. Let's say it has changed a little bit now, but anyway, it starts from nowhere, and with the available tools and available component we can provide to him, he's able to develop a new tool that will help his community. The second one is also another example. You may not know him because it's, let's say, not so much widespread now, but he has done something on the Kickstarter. So this guy, for people who have children, they will understand the topic. It's simply how to measure your consumption of water when your kids are under the shower. So simply, he's putting a kind of turbine inside the shower, and this turbine is making electricity, and is counting the debit of water. And then you have a lighting, and the lighting is changing depending on the volume of water going away. So here it is red, so it means that you have already gone over, let's say, 20 liters or something like that. Quite simple idea, I would say quite bright idea, and now it's working, and he's starting to develop his product. So, as those two examples, what we want to say is that there is a proliferation of this kind of object, and it comes from your ideas, and you implement that. So you have it in every kind of aspect of our life: the city, the car, the health, the fitness, and whatever. We don't know exactly where it will come from. We don't know. I mean, this is your ideas, and we are just here to offer you the tools and the means to deploy these ideas. I mean, this is our goal, and not to drive you into one direction. Few words about what is this IoT and this architecture of IoT. Clearly, as ST, and we are more on this side of the IoT chain. Of course, you have a big part, which is the cloud and the big data and the treatment of the big data. I must say, we have little to say about that. We are working on this aspect, but today this is not the topic of this conference. We are clearly want to focus on this, on those things. This is a very vague word, but it's on purpose. We don't know what those things are. You may know, and we are just trying to help you to create those things. So, in few words, what is happening now? I would say it will be quite obvious things that have been already presented before. Even the figures are the same, so it's quite good. So you have a proliferation of devices, of things that are connected connected in a way or in another. And then you have a proliferation of data creation, a huge amount of data creation that has to be managed afterward. Also, what we are seeing from a pure hardware point of view, this is also quite obvious, but this is really the thing, those three factors are the ones that are making those things I have presented to you before makeable. They were not makeable 10 years ago. Because of what? Because we have drastically reduced the key parameter of an hardware environment, which are the power, the power consumption, but also the power computing, enabling the power computing, I would say, the cost and the size. So typically, this is a Nucleo board. So this is a Cortex M3, this one, I think. Anyway, it's a M4. So it's a Cortex M4 microcontroller on a very tiny and cheap environment. This one cost $10. Huh? And this was not existing. This kind of things was not existing 10 years ago. And you were, to develop something like that, you were needing a very huge platform and a quite complex platform. So now, when you have an idea, what you want to do, what do you need to develop this idea? So, from our point of view, you are starting from, let's say, the microcontroller, which is the starting point of your platform, and then after you add on that some key functions, which are also now more and more available. We've been speaking about the sensor before. You have the motor control, you have the connectivity, so the Bluetooth and the NFC and whatever other kind of RF connectivity. And the third point is also proposing an environment which is an easy environment for the development of the ID. And this is typically the kind of things we'll present you more into detail after. Few words about our microcontroller, few words about the existing key functions that are available on the market. ST, we have plenty, but we are not the only one. And then a detailed presentation on our environmental tool by Daniel. So, just a few words about this portfolio of microcontroller. STM32, it's quite well known now on the market. It's one of the leaders of the microcontroller on the market for several reasons. Because it is the first one to be working on ARM originally, and because there is a wide portfolio. So any kind of ID you have, any kind of company, they can find what they want on this portfolio. So you have the ultra low power from up to the very high performance Cortex. Then on the building blocks, so what you need to add from this microcontroller to build your idea and to build your object. Here is a list of what is existing, what is available, what is affordable also on the market. So you have plenty of things on the sensors, which are environmental sensor, motion sensor, audio stuff, touchscreen, etc., proximity sensor. You have the controller, we discussed about that. You have the sensor fusion, which is the capability to make a fusion of all the information you have, which are more and more tricky things, that you have a number of sensors on your application, and you need a very big exercise of making the fusion of this exercise to extract the real information you need. And then, of course, the rest is the connectivity, so the RF connectivity, for example, and let's say the utility things, because you still need to power and to put some analog stuff. And the last thing about the way to develop is the tool. And so the idea is to make tool easy for you, for your development. So here we have put the 3 steps, the 3 user steps from an idea to the market. The idea for us is to try to simplify as much as we can this first step. The 2 second ones are quite tricky. We know that. I mean, it's a long way to go from an idea to the market. But at least for us, the idea is to provide you some quite, as we said, fast, flexible, and affordable tool so that you can start. You can have something on your hands quite quickly, and it works. And from this, you can start to develop your idea and to market your idea on the market and to go to Kickstarter or whatever to propose what you have in mind. And so the rest of the presentation will be more or less focused on this part, on what we are proposing in terms of software environment, open development environment, so that you can make your development. Up to you. No, I have just one word of conclusion. No, so just to finish as a conclusion, what we are saying that there is existing infrastructure that are here for years, thanks to the development of the smartphone, of the internet. You have many infrastructure, and what we have highlighted is what is coming now since few years is the availability of new technology in terms of electronics that are low power, small, quite cheap, and easy to implement. And this is what is making those objects, those small connected objects, this pew-pew or this hydrao, quite easy to implement, which was not the case in the past. And now it's up to you.
Now it's up to me. Okay, so what I do inside ST is more or less trying to provide some ecosystem around our hardware offer around the STM32. So what do we mean by ecosystem? It's of course the hardware, the pure hardware environment. So we have those Nucleo boards, but we also have discovery kits with more functions and evaluation boards that are more expensive. But this one is very interesting because it's cheap. And it's also available on all the STM32. So for each one, each time we have a new hardware, a new MCU, you have a Nucleo board that is associated with the same connectors and so on. So the one you developed on an F4, you can easily port it on L1 because it's the same hardware and the API will be the same also. In terms of embedded software, there are actually two main offers. Here we only see one, but we have the one we provide by default, which are the drivers for the peripherals, and then the different library we provide on top of it, the FreeRTOS, LWIP, the USB stack, and so on and so on. But also you have the embed approach. The embed approach is a different set of APIs built on top of the hard driver, and that enables you to quickly prototype your application and then flash it without having anything on your PC. The software development tools, we provide a set of tools that enables you to quickly go from choosing your MCU to the code generation. And the only thing you have to care about is your application. I'm sorry, I cannot write your application for you. And we have some website and selection and so on, so to be able to share what you've created. So the initiative of the open development environment is really to leverage all the offers that we can provide and our partners can provide on top of a common way to deliver, common set of APIs, common set to deliver, and so on. So the Nucleo board, the expansion board, and with the Nucleo boards, the Nucleo software that we provide, the HAL and so on, and the expansion software that is built on top of the same libraries. So that's how to do rapid prototyping. The idea is, as on those Nucleo, you have some Arduino connectors. You can basically plug any Arduino compatible shield, and you just have to port the API, of course. On our side, we provide some existing, ST provides some shields on top of the Nucleo with the APIs already ported, so you just have to develop your application. So the Nucleo itself, So it's always the same board. Every STM32 has this Nucleo board. Okay. You have the connectivity through USB on your PC, so you don't have to care about buying a dongle. It's already embedded on the board, and you can the ST-Link is supported by more or less all the development environments, IAR, Kyle, System Workbench, and so on. Atolik. It's very simple. It's 2 push button, 2 color LED. The idea is not to. It's not the board is not going to work alone. It's going to work with shields or stuff like that to build your real application. But it's very, very simple. Arduino extension, and if you want to access all the STM32 pins, you can access them through the Morpho connector. So what is the offer in terms of shields? So you can read almost everything you want to do. You can find a shield that would be working with the Nucleo. So in terms of audio, in terms of motor control, in terms of data process, and so on, sensors, and so on. So it's not always provided by ST, it's provided by partners, but there is a huge offer today. In terms of software tools, so the idea is, first of all, you start with the CubeMX tool. The CubeMX tool is the foundation for the ecosystem that allows you to go from choosing your MCU, configure the pinout, configuring the clock, configuring the peripherals, and then generate the code. So it works, of course. By default, you have pre-configuration set for the Nucleo, for the discovery, and so on. But if you have your own hardware, you can start with that. You can adapt to any hardware because you do the pinout you want, and so on. And it will actually do the conflict resolution of the pinout for you. Before we had that tool, you had to go through Excel files and see, oh, I want that signal on that pin, but I cannot because I want to put Ethernet and so on. With the CubeMX tool, it's completely done automatically. We have a set of partners IDEs. So the typical ones are IAR, Kyle, Atolik. We now have System Workbench for STM32, which is Eclipse and GCC DB based. And we have a tool called STM Studio. The STM Studio tools allows you to dynamically monitor the variables of your application while the application is running. So through GTag, we just read the memory, and you monitor, and then you can do graphs and so on. This is used a lot in terms of when you have application like motor control, because you cannot stop the application by breakpoints, because the motor can go crazy after. In terms of embedded software, we have quite a lot of large offer, I would say. First of all, the snippets. So snippets are just samples directly written on top of the registers to demonstrate how to quickly prototype something. Okay. Then you have the standard cube and the standard libraries. So the cube is, I don't know if I have a slide on that, but I think I have a slide, so I will explain later. Then you have the Embed SDK. So Embed SDK is an initiative promoted by ARM to be able to quickly prototype on a Cortex M type of application. So if you plug that Nucleo board on your PC, you will see a disk. So when you open the disk, you have, I think it's embed.html. You double click on it. You point to the embed website. You can develop your application on the embed website. You compile it on embed. You just retrieve the binary. You drag and drop the binary on the disk, on the virtual disk that is the Nucleo, and that's it. You flash your application on your Nucleo. And then you have a virtual compor. When you do printf on the Nucleo, you just open a terminal on your PC, and you will see the result of your printf. Then we have some more virtual machine and models. We have a Java implementation on top of most of the STM32, and we also have a MATLAB Simulink implementation, where you can, in MATLAB, directly do your application in MATLAB, run the MATLAB application in two ways, either completely on the target, or in MATLAB there is a mode called PIL, Processor in the Loop, so you can have the MATLAB, most of the MATLAB code running on the PC, but then some of the processing done on the target. So you don't have to run everything on the target. So in terms of information and sharing, we have the st.com website, of course. We have now an application running on a smartphone to be able to, for you to choose your MCUs. So you have your criteria and so on. The same you find in the CubeMX tool. And we have various forums and so on. In terms of feedback, go to the forum. Normally, there are quite a number of people that are answering on the forum. So to try to summarize here and give you a little bit more on what exists in terms of APIs, we have the HAL abstraction layer. So the HAL abstraction layer is portable on all the families for equivalent functions, of course. If you have low power functions that don't exist on the others, of course it's not portable. But if you want to do useart send, useart receive, it's going to be the same call for all the families. On top of that, you have a set of middleware level. TCP IP, it's a lightweight IP. We have FreeRTOS, FATFS, graphical EMWin implementation, and USB host and USB device. So that's the first set of APIs. The second set of APIs is the same sys drivers and embed enable drivers to enable you to quickly prototype. So to go a little bit more in details of what can be done with CubeMX, the first step you do with CubeMX is normally you choose an MCU. You say, I want to have Ethernet, I want to have Cortex-M4, I want to have this kind of power. And you choose your MCU. The second step is you do the pinout with the conflict resolution. You do the clock tree. Clock tree can be difficult to do. You just, in the tool, you just type the frequency you want, type enter, and the tool will find a solution for you in the clock tree. Of course, with all the constraints, I want USB, so my USB must be at 48 megahertz and so on. It will automatically compute that for you. It will then do the code generation. And if you want to compute what could be the power consumption, an estimate of the power consumption, you have a power consumption tool where you define the different steps. So I'm going to be 4 milliseconds in run mode, then 10 milliseconds in sleep mode, and so on. And it will give you an average consumption based on the peripheral you've chosen. And also an estimated battery life. We have a set of batteries. And so it will say your battery will last 3 months and so on. So it's quite a nice tool to use. On the Java front, we have a partnership with AS2T, with micro JVM running on the target, and with a set of Java APIs, so you can completely develop your application in Java. It's quite powerful. The macro GVM doesn't take a lot of memory on the or flash size on the MCU. It's quite efficient, and a lot of our customers use it for graphical application because it's very easy to develop a graphical application using the Java APIs. So already talked about the STM Studio, but the idea is with STM Studio is that you have a non-intrusive way to monitor your application. It's quite interesting. If you want to be a little bit more intrusive, you can, but it's not the idea. We have two modes of operation in STM Studio: one completely non-intrusive, one more intrusive, to make sure that we snapshot the variables where you want to, when you want to snapshot the variable. Okay, so as a conclusion, we try to make it easy, fast to develop on the STM32 kind of MCUs, to provide you the right level of API so that it's portable. You can start on one series. If you want more power or if you want less consumption, you can easily switch from one series to another and not have to rewrite completely your application. Everything is for free. It's open license. You can do whatever you want with it for all the tools that we provide. Any questions?
Any question? Good morning. Thank you for the presentation. Regarding connectivity, what do you have regarding IEEE 15.4 radios?
This is not provided by my team, but connectivity.
15.4, the low pan type of radios.
I'm not sure we have off the shelf. We have Bluetooth Low Energy, I'm sure. We have Wi-Fi, but I don't recall having a shield directly provided providing this kind of low band.
I suggest you think seriously about having one.
We know that we have partners that have developed some solution for electricity gathering, so to gather the counters and so on, and they have developed that on top of the STM32. So of course, it's possible to have that with the STM32 as the foundation, but I'm not sure we have the shield for that.
More question?
So, thank you, Daniel. Thank you, Roald.